Hello friends, let's solve some get questions on the data formats. So this is the first question. Consider the following binary codes processed on an Edison ALU, and these are the binary codes. We have these three questions. So what is the status of carry and overflow flags of the after computation, and result in decimal when the data is in unsigned format, and result in decimal when the data is in signed format. So we have these three questions. So let's solve the first one. So we need to find the carry and overflow flag. So we need these two numbers, and it is given that it is a decent ALU, right? So we need to add these two numbers. So let's talk about the A 101001000, and then we need to add this because we have given the addition arithmetic logic unit 10001011, right? If we add this here, 01 is 1, 01 is 1, 10 is 1, 01 is 1, then 00 is 0, 10 is 1, 00 is 0, and 1 is 10. So for this 10 we put 0 here, and 1 is the carry, and here there is no carry, right? Here we are finding the in and out carries because they are asking us to find the overflow flag as well. So from this we can see that we have this carry flag. So carry is equal to 1, and the in carry is 0 and the out carry is 1. That means overflow is also 1. And so overflow is 1. What type of overflow it is, positive or negative? So we can find this using, of course, two methods. The in carry is 0, that means it is negative overflow, and also the result is 0, and these MSBs are 1, so that means there is negative overflow. So this is satisfying this condition, x y z bar is equal to 1 because z is 0. So that's the answer for the first question. So the carry is 1 and the overflow is 1. Now the second one, B. So we need to find the result in decimal if we take the data in signed format, like unsigned format. So in the unsigned format, what we do is we take the accumulator content. This is the accumulator content, and put the carry flag value in front of the same, right? So suppose if the carry is 0, okay, let's write the accumulator content first. 00101111. If suppose carry is equal to 0, then we put 0 here in front of accumulator, but here in this one carry is equal to 1, so we put 1 here, right? So this will be 100101111, and this is nothing but 303, right? You can find, right, you can convert the decimal into like binary into decimal. Now third is result in decimal if the data is in signed form. So for calculating the result in the signed format, we need if overflow is 1 or not. If there is no overflow, the accumulator content is the result. Similar in the unsigned format. If 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 carry is 0, the accumulator is the result. If carry is 1, then we put 1 here. Similarly, if there is no overflow, the accumulator is the result. If there is overflow, if it is positive overflow, we put 0 before accumulator, and if it is negative overflow, we put 1 before accumulator. So we have seen these things a lot number of times in the previous videos, right? So here we have this overflow, and we have negative overflow because xyz bar is 1. Negative overflow means we put 1 in front of accumulator, so 1 will be there, and then 00101111. But this is the signed format, that means this is in 2's complement form, right? So these two are same, but don't write this as 303 because this is not 303, because this is in two's complement form. So we need to find the value of this data in the two's complement. So we can have the shortcut method. So there is no zeros, we write the first one here, and we invert all the remaining bits, that is 00010110. Now the value of this is 209, as it is negative number, so the answer will be minus 209, right? So these are the answers. This is the answer for C, this is for B, and this is for A. Now let's solve the second question. The second question is, consider the following 8-bit data computation. What is the status of a overflow flag and its expression? So we need to find if x y z bar or x bar y bar z. We need to find if like this one holds or this one holds in the computation. Minus 1 to 1 plus minus 63. So here we can see that the numbers are negative, but we cannot find if the format is ones complement or two's complement or sign magnitude, right? So what format we need to take? See, if in the question if it is given that it is ones complement or sign or two's complement, then take that format. But if in the question it is not given that the format is the numbers are negative, that means we need to take the two's complement method, because we represent signed data in the two's complement and this is the default, uh, right? So we take two's complement. Now we need to find the overflow flag. So you may tempted to use this method, right, to convert minus 121 to binary, minus 63 to binary, and then add those numbers and then find if there is in carry, out carry, or the expressions, right? So but this will take like more time, so we have other methods as well. So we use this method in the first question because we had already given the numbers in the binary. That's why we added like this and then found the carry and the overflow. But here we have given the numbers in the decimal, so you need to convert these numbers in the binary first and then you need to find, but we won't do that. Instead what we do is we will take the range conditions equation. So here we have given the 8-bit, right, 8-bit data. So in 8-bit 2's complement, we have this formula, right? Minus 2 to the power n minus 1 2 plus 2 to the power n minus 1 minus 1. So we can represent these many numbers in like if there is n bit. So if there is 8 bit, we have 2 to the power 7, right? So it would be minus 128 to plus 127, right? So we now know that in 8-bit we can represent minus 128 to plus 127. Now we will take these numbers, minus 128 minus 63, and then we plus it. So we will get minus this 4 and then 8 and this 1, minus 184. So clearly we cannot have minus 184 in this range. So we have this overflow and we have this negative overflow, right? So overflow is equal to 1 because this number is lesser than minus 128. So we have negative overflow, and we know that for negative overflow the z is 0, means z bar is there. So x y z bar. So this is the expression, right? So the what is the status of overflow flag? It is 1, and its expression, this is the expression. So this is how we solve this type of questions. Now we have one more question. The third question: consider the following status present in the hardware after processing the binary code. What is the result in decimal? So we have the accumulator content and overflow flag, that is 1, and we need to find the result in decimal. So to find the result, we have this, that overflow is equal to 1, but we need to see we if we need to add 0 or 1 here, we need to find if it is positive overflow or negative overflow, right? And then if it is positive overflow, we put 0 here. If it is negative overflow, we put 1 here, uh, right? So this is very easy because this accumulator is used for storing the result, and here MSB of accumulator is 1. That means it is positive overflow, right? The expression is this one: x bar y bar z is equal to 1, right? Z is 1 here, and this will be, of course, like x and y will be 0. So this is the positive overflow. right? So after knowing that it is positive overflow, for positive overflow we put 0 in front of accumulator, so accumulator is 100111011. If suppose it is negative overflow, then we could have put 1 in place of this 0. So this is nothing but 1 plus 155. No need to convert like invert and add plus 1 or apply the shortcut method, because here at MSD we have 0, so this number is positive, so we will report the result directly, that is plus 155. So that's all for this video. Thank you so much.